So the first type of preparation that the book talks about is using string functions. So I'm going to go ahead and open a new tab in my browser, and I'm going to search for pandas series. And this should take me to the pandas series class. And this includes a list of methods. And then towards the bottom of that list, you're going to see series.dt, which is an accessor for date time series. And then series.stir, which is an accessor for string and object type series. And there's also series.cat, which is pretty small, but it's an accessor for some information about categories. And there's also series.sparse, which is an accessor for sparse arrays, which we're not actually going to look at that much. But these are all different accessors that have different methods associated with them. The string accessor has the most methods associated with it. So if you look at all of these stir methods, capitalize, casefold, concatenate, center, a text in a field with, and contains, and so on. Lots and lots of stuff here that you can play with. But there are also ones for dates as well. So for example, if you have a column with dates in it and you want to pull out the month component or the year component or so on, then you can do that as well. And same thing with categories. So let's go ahead and take a look at how some of that is going to work. And for an example, I thought it would be instructive to look at the mental health in IT dataset. So if I can find where that is. So here's the mental health in IT dataset. And right now, we were just working on this so that it pulls out only the rows where the position doesn't have a bar in it. So this position column here uses bars for people that have multiple positions, vertical bars. So let me see if I can find the position column here. So this is before we filtered it. So which of the following best describes your work position? And you'll see, like this example right here, this is a person who reported being both a back-end developer and a front-end developer, and it uses a bar as a separator here for multiple values. So in the first version of this, what we're doing is we're filtering out all of those rows where a person has listed multiple values there. And that's certainly one valid way of handling it. But we might also want to include all of the roles that a person reports so that we can score all of the positions that a person has rather than dropping that data out. So I'm going to go ahead and make another cell here. And let's start by reloading all of that data. So let's reread the CSV file down here. And then I'm going to go ahead and also do the renaming that I did before. And actually, let's go ahead and grab, I'm not going to filter this. I'm just going to go ahead and do this rename. So df is equal to df dot rename columns. And then let's do selected is equal to df. And then I'm going to pull out position and diagnosed. And let's print it. And then let's also grab this thing about converting diagnose to Boolean. So this is, oh, and then I really want to do this to df. So let me go ahead and do that here to df. Great. So now I have basically what I had before, but I still have these bars in. And now what I want to do is, it's going to take me a couple of steps. But the first thing I want to do is I want to pull out all of these strings. And anywhere where I see a bar, I want to split the value into basically a list of values. So in Python, there's a split function, and it takes a string. So for example, I can write, let's print foo bar baz split on bar. So what this is going to do is it's going to take the string foo bar baz, and everywhere where it sees a bar, it's going to split that into separate strings in a list. So let's go ahead and look at what we get. So we get a list of values, foo up to the bar, and then bar up to the next bar, and then baz. Now, I can do something similar by using the stir accessor on selected. So I can say selected subposition, and that's going to return a series of string values. And then str is going to give me this thing called a string method's accessor. So this is just a convenient place to park some methods that operate on strings. And the one I want is this split function on a bar. So if I go ahead and execute this now, the ones that don't have bars, I just get a list of single values. But the ones that do have bars, I get a list of multiple values in here. So one for each thing. And some of these are longer than others. So for example, if I take this stir.split, and then I can like apply a length function to that. So I'm going to show you something called a lambda function now as well. So normally what I would have to do is I'd have to define a function like list length, and it's going to take a list and it's going to return the length of the list. And then if I have a function like that, I can apply it like so. And so this is going to return the number of components in each of these split lists of strings here. So this one actually has 7 different positions. And this works perfectly fine. So it's going to run this function on each of these lists and return the length of the list. But this is a little awkward because I have to define the function, and sometimes you just want to do something simple without having to define a function. And you can do something like that using a lambda. So lambda is basically an anonymous function. It's a function that doesn't have a name. And you say lambda and then a list of parameters that it's going to take. In this case, it's just going to take one value, which is going to be a column, and then a function to apply to each value in that column. So here, I'm going to return the length of x. And you see I get the same result here. So lambda of x, length of x, means take each value in the series, apply the length to it, and return that value here, just like if I defined a list length function and passed that in. So that's convenient shorthand. And then now that I'm pulling out the separate values, I can do some additional things here. So here I'm going to go ahead and split the length. And then what I can do is I can actually add this back to the original data frame. So I can say selected square bracket split position is equal to selected position dot split, and then I can look at the new data frame, and it's giving me a warning that I'm modifying a slice. So let's go ahead and just do all of this in the original data frame. Okay, so here's my original position string, and here's the split version in a list. And now another function that I can apply off of the data frame is called explode. And so explode will take a list here and will create a separate row for each of the values in this list, along with copies of all the other columns. So for example, backend developer, I'm just going to get one row with these values. But this person, person 2, I'm going to get one row for backend developer with these two values, and another row for front-end developer with those two values. So let's look at what that looks like. So if I say df.explode, and then I give it the list or the column name that I want to explode on, here, you see I have two copies of this row 1, one with backend developer as the split position and one with front-end developer as the split position. So now, now that I have this, I can aggregate in two different ways. I can aggregate only the columns where there are no duplicate or no multiple values. And here I can aggregate each of the individual values that somebody claims. So if they say they're both a front-end developer and a back-end developer, I can group it both ways. So now let's go ahead and group this data. So I want to group by the split position and then count up how many people were diagnosed with a mental illness or mental condition and how many weren't. So what I want to do is group by split position and then sum up the value of diagnosed. And when you sum Booleans in Python, basically false is 0 and true is 1. So I can add group by split position and then sum the numeric column. And actually, I probably misspelled group by there. Yeah. Okay. So this group by split position and then summed up the people who said yes, that they were previously diagnosed. And actually, what I probably want to do here is instead of sum, let's take the mean. So that's going to be the average, which is basically the ratio of the people who said yes to everybody. So we see basically percentages. We can multiply by 100 to get a percentage. So this is the percentage of people who said yes, they have been diagnosed. And now we can also order these. So let's go ahead and then mean and then we'll order by diagnosed. And then ascending is false. So this is going to float the highest scores to the top. And this one does have an underscore. It's actually sort values, not order by. Sort values. There we go. So now you'll see that diagnosed is in descending order, and we see that the job positions that reported the highest percentage of people who had been diagnosed with mental conditions were designers, HR, developer and evangelist advocates, other, and then support, sales were towards the middle, one person shop was towards the middle, and then supervisor, tech lead, executive leadership, back-end developer, front-end developer, and DevOps sysadmin were on the lowest end of the spectrum. So I'm not going to draw any conclusions about that, but I think it's interesting. Now, one thing to be aware of here is that some of these categories still have relatively few examples. So what I might want to do is let's go ahead and add another row here. And I'm going to do this group by again. So I'm going to split by position and then group by split position, but this time I'm just going to count. And when you count them, you see that some of the positions like back-end developer, there's 737 rows in the data set that reported back-end developer, but some of them like HR, there's only 12. So relatively few, sales relatively few, only 31. And so any percentages for these rows are going to be much more suspect than the ones where there's a lot of data. So that's the first thing I'm going to note. And then the second thing that I'm going to note here is that these percentages are really high for people who are reporting being diagnosed. So there's probably something else going on in either the way that this survey was conducted or who was asked to participate in the survey, because you wouldn't really expect half the people that were surveyed to report having been diagnosed with a mental condition. Specifically, have you been diagnosed with a mental health condition by a medical professional? If more than 50% of people who were asked that question are responding yes, then it's probably not a representative sample of the population as a whole. So we'd need to know more about how the survey was actually conducted and how this data was gathered to know why there was such a high percentage of people who reported having been previously diagnosed.